Today we will discuss on the topic of sentiment analysis. You can't transform something you don't understand. If you don't know and understand how your customer experiences, how will you improve? Nowadays, getting customer reviews for your products and services has become very easy. Previously, the only way for a customer or consumer to reach companies was through sending a letter to the company office. That was the only way that they could, give their feedback of the product or service to the company. And most of the time, these letters did not even reach the company. And even if they did, they weren't taken seriously because back then, consumer experience or consumer feedback was not exactly a area which companies focused on. Consumer feedback now plays a central part in the success or failure of a company. You can the way whether a company will progress or not is decided mostly by the way they deal with customer reviews, because the only way that a company can survive in the ever changing market nowadays, in the constantly changing market nowadays, is by constantly improving. Now you can write reviews of a product or service on Instagram, Facebook, Twitter, Amazon, Google. It will take only 5 minutes and your review will be right there. In 5 minutes, your review will have reached the company. So there are many ways in which consumers can reach the company now and highlight areas of improvement. Due to the ease with which reviews can now be displayed online, many people write reviews. The result is that the companies now have a constant stream of feedback. People are constantly writing reviews online on different platforms, and the companies can now focus on improving the customer experience. So the companies simply analyze the sentiments and keywords in customer reviews to understand where they have to improve. For example, someone dropped this review: bad customer care, took hours to respond. Here, the sentiment is negative and the keywords are customer care and response. So, using sentiment analysis, what simply will happen is, by getting the sentiment which is negative and the keywords, the company can know where it has to improve and can take immediate action. Customer review segmentation is used to find what the company is doing right versus what the company is doing wrong. This allows companies to constantly improve and prevent problems before they have turned more severe. By segmenting customer reviews, you can rank areas of improvement based on the number of reviews highlighting each area. So, if one area of your business has more complaints, then that will become your priority. If a company has more positive reviews, then more customers will be willing to buy products from the company. Using sentiment analysis, companies are able to prevent complaints from being ignored and are able to prioritize more serious complaints based on the tone of the review. So, if the company finds out that its customer care has received a lot of negative reviews, it will immediately prioritize and try to find out what it's doing wrong and will take swift action. The way the companies previously dealt with reviews was they would take the reviews, give it to a group of people who would analyze the reviews, go through all the reviews, and then they would write down which area of improvement had the most reviews, like which complaint had the most reviews, and then the company dealt with that complaint. Because back then there were few letters that used to come, so any employee could draw that task and finish it in half an hour, because maximum there would be 100 letters. But now, with the evolution of the feedback, the way people drop feedback, companies cannot deal with reviews the same way as before, because there are too many reviews and they cannot use their employees, their time and effort in doing this, because there are too many reviews for a group of employees to be able to go through. So the way companies decided to solve this was by using machine learning. A machine learning model takes the data of the reviews from the web and then returns which areas need to be improved on. So what does the machine learning model do, and why do companies choose machine learning? What machine learning does is it studies past data and learns from it so that it can make predictions of future data. There are many advantages of using machine learning in this field. It requires less time, little to no expense, and is fully automated, requiring little work from humans. But machine learning has its own set of challenges as well. We will be analyzing sentiments of Twitter data, but you can use the sentiment analysis project in many other ways. So the first challenge that you face when using machine learning for sentiment analysis is it takes too much processing time because there are so many reviews. If it is a big company, then it will have a lot of reviews across a lot of platforms. It could have 5,000 reviews on Amazon, 500 reviews on Instagram, 200 reviews on Google. Processing all these reviews for each product can take a lot of time. We will also be facing this problem in a way since we will be analyzing Twitter data of 1.6 million tweets. Second problem is that models do not understand the actual meaning behind words. So in order for your machine to understand words, as machine can only understand numbers, you will have to convert your words to numbers. But all that will do is it will tell the machine where the words were used. But the actual meaning of the words is not conveyed to the machine by converting your words to vectors. Because, for example, TF-IDF. Using TF-IDF, you can only highlight important keywords, not the actual meaning of the words. So we need a method that can help the machine understand the meaning that a word is trying to convey. Now there are many ways of approaching a problem in machine learning. The conversion of words to vectors has more than 5 methods. But the most popular ones are one-hot encoding, bag of words, and word-to-vec. The reason we are not using one-hot encoding is, firstly, it does not understand the actual meaning behind the words. And secondly, one-hot encoding creates way too many features. The way one-hot encoding works is that it creates a separate column for every word. And then, as the word appears in that particular review, it types the value 1 in the column of that word to show that the word was present here. However, this creates way too many columns or features for our machine to handle. Word2Vec solves both of these problems. It is able to capture the meaning behind the words while not using too much space. Artificial neural networks, or ANN, is a deep learning algorithm. RNN is also an algorithm which is of deep learning, which means recurrent neural networks, and both of these have some common problems. ANN is when you use, or a neural network is when you use a network of neurons to analyze your data. So first you pass in the input to an input layer of neurons. For example, here the light blue neurons are the input neurons. They take the input and assign a random weight to every input they receive. So in our case, all the words in the Twitter tweets. A weight is simply the importance that you assign to a variable. For example, if we used an artificial neural network to detect humans through a camera, it would search for a set of features. Does it have legs? Does it have eyes? Does it have a tail? Each fit these three features will have a value assigned to them. And this value will show what effect their answers will have on the output. So for example, you take the equation of a line. So you're trying to capture the relation between house price and area. So obviously your line will start low and then go higher. As your area increases, your price will increase. The equation of that line would be y equals mx plus c. But now, for example, you have multiple variables, multiple x variables, and you are trying to predict one y variable. Y variable is still house price. But x variable is area in square feet, number of bathrooms, whether it has parking, etc. So what will happen is your x variable will, because there are so many, they will each have a separate slope. So they will each change differently as they increase or decrease. So they will have a different weight. Weight is simply the amount they change, the amount of importance they are given. So simply weight means for how much change in your x is will y be affected. So in this example, y is equals to w1 x1, weight 1 x1, plus weight 2 x2, plus weight 3 x3, plus c. So in our case, y equals number of bathrooms into zero point 0.3 plus number of plus whether it has parking into 0.2 plus area into 0.5. In our case, we are giving more importance to area. Why? Because area is considered to be a very important point when you go to buy a house. It matters more than whether you have parking, because parking can be arranged. So now, based on the input, neurons get some values, attach the weights, and pass it on to the hidden layer, which is the term of the gray cells. The hidden layers are the layers of neurons between the input and the output. So the gray cells or the hidden layer takes the values from the three neurons and applies weights to each of them, as they have experience as to which neurons should be given more importance. So the equation becomes y equals weight 1 into n1, which is simply weight 1 into neuron 1 plus weight 2 into neuron 2 plus weight 3 into neuron 3, where n is the input neuron's output. After this, they will forward the value to the output neuron, who applies weightage to their output. So variable A and variable B, their values will also be applied a weightage to. And based on that, the output neuron will give a prediction. Now, if the prediction is wrong, the neural network will back propagate. Simply, it will go back and make changes to the weights, so that every cell can adjust its weight according to the error. And after such trial and error, over time, the artificial neural network learns how to accurately make predictions by giving the right weights or right amount of importance to the right features. However, in this whole example, there is a problem which occurs in neural networks. This is called vanishing gradients problem. When you are back propagating or coming back to change the weights, or the value by which you will adjust the weights is your new weight will be equal to your current weight minus your learning rate into gradient. Learning rate is a fixed value which you multiply to the gradient. It is usually a small value, 0.1, 0.01 or something. Gradient is the important part. Gradient tells us how much of an effect does a neuron or feature have on your output. So what will happen is the way your gradient will be calculated is derivative of loss upon derivative of weight 7 in the case of variable A. So if we want to know the gradient for variable A, it will be the derivative of loss upon derivative of weight 7. So what is derivative? Derivative measures the change in one number, in one factor. So what the above equation means is that for a given change in weight 7, how much does loss change? So for a small change in weight 7 like 0.01, how much is that affecting our final output? So if you want to see the gradient for weight 1, so if you want the gradient for weight 7, you will find out how much will I, so if I make a change of 0.01287, how much is our output changing? You will take that value multiplied by the learning rate and subtract it from your current weight. If you want to see the gradient for weight 1, however, you will have to use a different equation. That is this: derivative of loss divided by derivative of weight 1 is equals to derivative of loss divided by derivative of variable A into derivative of variable A divided by derivative of weight 1. So simply derivative of, so for a given change in weight 1, how much will loss change? The answer is, you will have to take the value of how much the loss will change for a given change in variable A, and then how much the variable A will change for a given change in weight 1. And then by using these two values, you can indirectly find out how much variable weight 1 will change your final output. Now all these values will be very small, and when you multiply two small numbers, you will always get an even smaller number. By small number, I mean numbers with decimal values. Now this is a small neural network with only 3 layers, but there are neural networks with 30 layers, and if you multiply each derivative with the other to reach the weights of the first layer, you'll have to go like, okay, derivative of loss divided by derivative of weight 1 is equal to derivative of loss divided by derivative of variable z, and then into variable derivative of variable z divided by variable derivative of weight 7, and you'll have to come that far back, and by the time you get there, the value will be, or your gradient will become so tiny that the weight will not change at all. So your first layer will simply not change, it will remain the same despite an error. So your model will stop learning, it will stop improving, it will get stuck, and this is vanishing gradients problem. And the more your features, the more this problem increases. So to deal with this problem, there is LSTM. LSTM solves this problem, and that is why, as our data is going to be large and require a large neural network, we will be using LSTM. Here I have given an overview of how a deep learning model will work. We will first get our data from the web, apply stemming and stop words, split data 80% to training set and 20% to testing set. Training and testing simply refer to your model learns, practices on the training set, and then tests itself on the testing set, just like a human being. The training set is like your textbook. When you go to school, the first many days, you are allowed to study. You are given math sums and you're allowed to study. And then on the last few days, you are given an exam. Now when you were studying, you were given the question and the answer. So you looked at the question and the answer and tried to understand how did the answer of the question, how did the solution to the question arrive. In the testing phase, you are not given the answer, you are just given the question, and based on what you have learned previously on the training set, now you have to predict the answer, and then you will get to know, you will get a score whether how much you are right and how much you are wrong. So that is training and testing. So we are giving 80% of our data to training and 20% to testing. Then we implement word2vec, and our word2vec will run 32 iterations on our data. Simply it will go through our data 32 times. Then we will tokenize our data. Tokenize simply means you will convert every word to a separate column. You will break the sentences and deal with every word separately. This will give, and then we will do label encoding. Label encoding will give each result a unique number code. So as our tweets can have 3 possible sentiment results: negative, neutral and positive. So 0 for negative, 2 for neutral and 4 for positive. Then we will implement our LSTM model, which will run 8 times on our data and get our accuracy score, which will be around 80%. So let's talk about tokenization or our data pre-processing. Data pre-processing is when you are preparing the data to be worked on by the model. So we'll have to convert our words into numbers. So we will first remove all the stop words. What are stop words? Stop words are words which don't add anything new to the tweet. They are a list of words used by humans to make the sentences complete, but the machine only needs keywords. It doesn't need words like is, the, for, as they are not keywords, and so they don't have any sentiment or importance attached to them. So it removes them. Next, we will apply stemming. Stemming simply takes away all the letters which are not there in the root word. The root word is the actual word on which, after applying a suffix, the current word was derived. For example, the word played and the word playing are examples of the same root word play, with different suffixes at the end. One is using ed, played is using ed, and playing is using ing. So different suffixes are applied at the end. If we remove these suffixes, we reduce the word back to its stem, we get play. The stemming will remove all the suffixes since our LSTM model does not require them. After that, tokenization splits each and every sentence into words. So instead of having the whole sentence or tweet in one row, you will have only one word in a row. This way your neural network can train itself on each and every keyword. Word2Vec is used to convey the actual meaning of a word to a machine learning model. The way it does this is it takes a group of words and checks them against some conditions, and based on the answers generates a numerical output. Simply, if you had the word cat, it checks for a list of conditions or features. Is it a living being? Yes. So assign a value between -1 and 1. In this case, since the answer is mostly yes, it will assign a value like 0.6. Is it feline? Yes. Assign 0.9. Is it human? Not exactly, but it shares some aspects with humans, so it will assign something like 0.1. So it's unsure. Royalty? Definitely not. So -0.7. So now the vector or the numerical representation of the word cat, the numerical form, will be 0.6, 0.9, 0.1, -0.7. But if every word has so many features, the computation will once again become very large. So what Word2Vec does is it compresses the vector into a 2-feature vector or 2-variable vector, 2-number vector. The result is that the machine, by analyzing the features of two words, for example cat and kitten, can realize that the two words are very similar and that cat and houses is not similar as their features don't match. So how it did this, first of all it got these features and then it multiplied them or did some mathematics on them to multiply these 4 features and convert them into 2. In this example on the screen, it has converted 7 features into 2. And then based on what those features are, as they are derived from the 7 features here, you can see cat and kitten are very similar, living being very similar, both are feline, both are not royalty, while cat and houses are completely different. One is a living being, one is not a living being. Houses are not feline at all, while cats are feline, right? So that's how it understands which words are similar. Word2Vec uses skipgram and continuous bag of words to understand the reactions between two words. Continuous bag of words takes a target word which it selects and then tries to derive from it the context words or words surrounding it, thus understanding the relation between them. Skipgram takes the target word and tries to derive the context, thus allowing the machine to learn which words appear more frequently with each other. Continuous bag of words understands which words are more similar in their alphabet structure, like cat and cats are similar, with the first 3 letters being the same, while skipgram understands which words are more similar conceptually. The way TF-IDF vectorizer works is it takes an article and finds the keywords. So it will, in our case, it will take the tweet and find the keywords. It does so by using two concepts, TF and IDF. TF is term frequency, which is the number of times the word appeared in the article. So in the example A, the word Jupiter appears once. The term frequency is equal to the number of times the word appeared in the article or sentence divided by number of total words in the article or sentence. So in this case of Jupiter, it appeared once in this sentence and the total number of words were 5, so it's 1 upon 5. IDF is inverse document frequency, which is the number of articles or sentences the word has appeared in compared to the total number of articles. It is mathematically calculated by log of number of total documents divided by number of documents the word appeared in. So in our example of the word Jupiter, it appears in one sentence out of two total sentences. So it is log of 2 divided by 1, which is 0.69. The more articles the word has appeared in, the lower the inverse document frequency will be. So when we multiply the TF with IDF and get our TF-IDF value, which it will remove all the unnecessary words, leaving you with only the important keywords. You can see useless words like is and the, which are not adding anything, have a TF-IDF value of 0. So what this does is, in case you are given a fake news about Jupiter, Jupiter is the smallest planet. Here the keywords after TF-IDF will be Jupiter, smallest, and planet. TF-IDF will then verify these keywords against articles on Jupiter that have been published before. Simply IDF. It will go through where in the article has this word smallest appeared in relation with Jupiter before, and will find the keyword largest planet with Jupiter many times, but it will never find the keyword smallest planet appearing with Jupiter, because Jupiter is the largest planet in the solar system. So this way our TF-IDF vectorizer will identify fake news. In label encoding, we are just giving a different number to each possible result. So in our case, negative will be 0, neutral will be 2, and positive will be 4. LSTM, as we discussed earlier, solves the vanishing gradient problems, which turns many features to meaningless as they are unable to improve by remembering the important features and their weights separately, so that it does not have to back propagate and multiply every value by the weights to adjust. A confusion matrix is a way to summarize the classification result of an ML model, machine learning or deep learning model. It contains 4 sections: true positives, true negatives, false positives, false negatives. True positive means that our model predicted positive and it was positive. True negative means our model predicted negative and it was true, it was correct, it was negative. False negative means when our model predicted positive but it was actually negative. And false negative means when our model falsely predicted it to be negative but it was positive. Now let's get to the programming part of the project. We will be using Python and a software called Jupyter Notebook. First, we will import necessary libraries. Libraries simply consist of large blocks of code which are given names. So simply you can use the names to call them instead of writing the whole blocks of code. Earlier there were no libraries and you had to manually code everything yourself. For example, if you don't know the name of a person and want to talk about him to a friend, you will have to ask your friend the person's name by giving a list of his features. So the only way you can convey who you're talking about is by giving the whole list: how he looks, what he wears, where you saw him, etc. And then your friend will recognize him and give you the name. When you start using the name, you no longer need to describe the person again. You can just take the one word name and your friend will know who you are talking about. Similarly, when using libraries, you don't need to type in the whole code. You can just call the code from the library and use it. Different libraries are used for different use cases. NumPy is for math. It handles all the math operations like mean, median, mode, etc. Pandas is for handling and changing your data. If you want to remove a column or add a row, etc. sklearn is a very important library which has a lot of important machine learning functions in it. TF-IDF vectorizer, label encoding, confusion matrix, etc. We will also be importing Keras library which has important deep learning functions in it. Here activation refers to the function that will be used before giving us the output. We will be using the sigmoid function to get a probability of our output between 0 and 1. So the probability of it being fake news between 0 and 1. Dense here in the I think it's the fourth line here, dense refers to the fact that we will be creating a dense neural network. In a dense neural network, every neuron is connected to the other. Dropout is when we drop a set of neurons for every feature so that none of our neurons are overtrained on one specific variable. Every machine learning or deep learning function has a set of parameters that have to be passed through it. Parameters are like, you're describing exactly what you want. So here we are declaring our factors or parameters early on, as it is easier to deal with them if they are all stored in one place. We are declaring our column names, training size, how many epochs or iterations our word-to-vec will run, how many minimum words it will deal with in a time. Now here we are declaring how many epochs or iterations our LSTM model will run, how many words will it take in one batch. And the sentiment threshold simply mean they are simply saying anything below the low threshold or the first threshold of dot 4 will be negative. Anything would mean dot 4 and dot 7 will be neutral, and anything above dot 7 will be positive. Now we are reading our data into our program. For this, you will need to provide the file path so the program can go to the file, address, and get the data. Then we are printing the length or number of records in our data. And then finally we'll printing the head, which are the top 5 records of our data. And you can see this is how our data looks. You will notice your values start by 0. So your records are 0, 1, 2, 3, 4. The first element of a dataset is always remembered as the 0. Here we have the name of the user, the date, the ID of the tweet, and the text inside the tweet. Now we are giving our sentiments their numerical values and applying this on our entire data by using lambda function. This final piece of code creates a plot which will show the number of records for each sentiment from our data. So the number of records which are neutral, number of records which are positive, and number of records which are negative. Here we are removing the stop words. The reason we are saying stop words English is because there are stop words of many other languages present in Python. But since we want only English, we are passing English as the parameter. We are then saying that if the following word is not present, you can see if token not in stop words. So if the following word is not in the stop words, only then stem it. Since we don't want unnecessary computation, why should we stem a word which is going to be removed in the next phase due to it being in the stop words? And then we are executing this function on our whole data by using lambda. Here we are doing train test split. Our train size is 80 and our test size is 20. Random state is used so that you can get the same set of random values again. Simply the number 42 in this case can be used to generate the exact same random records using the same data. So if you are working on a project you can all use the same random data by using the random state value. It is like it generates a seed or a key which can unlock those records. Now we are checking the number of records. Here we are checking in the end the length of our train and test set. So we are checking the number of records in our training and testing data. Our training data will contain 1.28 million records, while our testing data will contain 320,000 tweets or records. Here we are implementing word2vec and using it building our vocabulary. A vocabulary is just the list of words used in your overall data with their vectors. And then finally we are testing our word2vec to see whether it is working accurately. We are checking which word does it find most similar to love. Now we are tokenizing our data into one token per row format and checking the total number of words in our vocabulary. Here we are encoding our target variable or sentiments to the values 0, 2 and 4. And then we will be running our word2vec through an embedding matrix which will avoid the problem of higher values. What happens is any word which is converted to a high vector automatically gets treated as more important, because the machine thinks that this number is bigger, it should be given more, it's a bigger number, so it should be given more power. But we want all of our words to be treated equally, so for that we will be using embedding layer to convert all our word vectors to values between 1 and 0. So instead of 32, 49, you will get something like .137, .246. Now we are defining our LSTM model with our dropout and activation functions before getting a summary which will tell us the number of parameters our LSTM used to train and how many neurons every layer has. Here we are using binary cross entropy as our loss function and Adam as the optimizer. Optimizers define how you should change, how your model or your LSTM will change the weights or learning rate to achieve the lowest possible error. Loss function defines how your loss is going to be calculated. Now we are getting the score and loss of our model to see how it performed. Here we are defining how our data is supposed to be treated if neutral is an option versus if it isn't. So if neutral is an option, it's going to say, okay, if score is less than our sentiment threshold 0, which was .4, then label is negative. If it is more or equal to, if it's equal to the sentiment threshold 1 or more than it, then positive. Else, if we don't have a neutral, then anything below .5 will be negative, anything above .5 will be positive. Here we are using something called pad sequences. So what pad sequences does is, since all vectors are not of equal size, and we want all words, like all words are not of equal size, so of course all the vectors will also not be of equal size. Now because of this, the machine learning model can get confused, because the machine learning model wants all the variables to be of equal size to be able to deal with them. So we will need to fill the empty spaces with zeros. For example, the biggest word in our vocabulary, if the biggest word is collaboration and smallest is cat, since collaboration has 13 letters, we will need to give cat also 13 spaces for our letter, 13 letter spaces, right? So the last 10 spaces will be filled with blanks or zeros, since cat only uses the first 3 letters. Here we are defining how our model will display predictions of our data. So when our model shows the predictions, it will show the sentiment that it has, decided it represents, the word, which sentiment it found from the tweet, how much time it used, and what is the confidence level. And now we are printing our confusion matrix and getting our classification report. A classification report consists of 4 things: precision, recall, F1 score, and support. Precision tells you what percentage of your predictions are correct. So precision for negative is how many of your negative predictions were correct, and precision of positive was how many of your positive predictions were correct. Recall tells you the percent of positive cases or negative cases that you correctly classified. F1 score is a mean of precision and recall, where the best score is 1 and the worst score is 0. Support tells you the number of instances of each result in your dataset. So there were uh, close to 1.6 lakh negative tweets and 1.6 lakh positive tweets. So overall, our deep learning algorithm has solved all of our problems. It has solved the problem of too much processing time by removing all the stop words and applying stemming before applying TF-IDF vectorizer to only leave the most important words, keywords. The model has captured the meaning behind the words thanks to Word2Vec, and the model understands which words are more impactful or supportive or negative due to LSTM. So overall, this model is very good, has a high accuracy, but there are still some improvements. We haven't dealt with emoticons or emojis. They don't appear much on Twitter, but if you are analyzing text message data or WhatsApp data, then it will definitely be a problem. But overall, this is one of the best possible solutions using the most recent and advanced model and learning algorithms such as Word2Vec and LSTM.